Here's my special can with some unusual properties. I'll roll it towards the camera. Now, just come back, please. Wow. And come back again. And note how it rolls back and forth. Do that once again. Comes back. How can we explain the unusual characteristics of this can? It certainly doesn't seem to go along with our normal experience of rolling cans. A good activity with the students is to actually ask them to come up with explanations and to just write the explanations on the board without being judgmental. Give the students a chance to come up with as many different explanations as possible. And then after you've got a list of 12 or 15, you can then go through each one and say, is that a reasonable one? Is that one that would coincide with your experience of what you know about cans and about the properties of whatever it is you're describing? And perhaps somebody will come up with the correct explanation. If not, you can then show what's inside the can. So let's open it up. There's an elastic attached to the lid. And inside the can is actually a mass hanging on the elastic. So let me take it out. What I have inside is an elastic on which I have hung a heavy bolt. Either end of the elastic is attached to the bottom and the top of the can. And I've actually fastened a paper clip to the lid by using some hot melt glue. And the best way to get it to stick is to actually heat the metal. You can notice it's a little bit brown from heating on an alcohol burner to make the metal nice and hot, so when the hot glue goes on, it will adhere well to the metal. And we do the same with the inside. So inside the can is also a paper clip at the center. And it's a little bit trickier to get in place, but you can drop some molten glue into the center of the can, heat it up, again over an alcohol burner, and place a bent paper clip in the bottom, in the glue, and then allow it to cool, and that will hold it firmly. When the can rotates, the elastics wind up, and that gives the elastic potential energy. And so as the elastic winds up, it has potential energy, and when it's wound up fairly tightly at the end of its rotation, it then exerts a force on the can in the opposite direction, causing the can then to rotate in the opposite direction, unwinding the elastic, and then it goes back to where we started and beyond, and it winds it up in the other direction and comes back again to the starting position and beyond. So the mechanism is actually very simple, but it certainly is a puzzle for the students. It's important when assembling the elastic that the elastic not rotate through a loop in the wire. To show you a close-up of the way I've hooked it up, I put one section of the elastic through a loop, and then I bent the wire around again to catch the second loop so that the elastic cannot spin in the wire. It doesn't really matter what size wire you're using. I use a number 12 copper wire here. A number 14 copper wire works fine, or you can use iron, anything to hold it in place. The heavier the bolt is, the tighter the elastic can be wound up without the weight spinning over like this and unwinding by itself. You can attach a rock or any heavy object as long as it doesn't touch the side of the can.